Today's lesson is on angles of a triangle. Although we know what a triangle looks like, we need to break it down. So we have a triangle's form of three sides, which are segments because segments can be measured and the sides of a triangle can be measured. It is also made up of three non-collinear points, each called a vertex. So it's non-collinear because the points are not in a line. And every triangle is made up of three vertices. There's a vertex at every spot where the two segments meet. One way we can classify triangles is by their sides. So we have the yellow triangle here is a scalene triangle. And a scalene triangle is a triangle that has no sides congruent. So we can show that a number of different ways. We can have different hash marks, so 1, 2, or 3, meaning that they're not the same. We can have values like this is 5, and this is 8, and this is 9. So we know that none of the sides are the same measure. We also have an isosceles triangle. And although we know that a isosceles triangle has two sides that are congruent, so we can say these two sides are congruent, the definition is actually a triangle with at least two sides congruent. And the last type is an equilateral triangle. So this is an equilateral triangle here. And that is when all three sides have the same length. So if we look back at the definition of isosceles triangle, it is a triangle with at least two congruent sides. So this triangle right here is actually an isosceles triangle, but this triangle is also an isosceles triangle because it has at least two sides that are congruent. Now, although that's true, when we talk about isosceles triangle, we're usually looking at this type, the type where there are two sides that are congruent. We can also classify triangles by their angles. So for instance, we can have an obtuse triangle that has one obtuse angle, meaning that the angle is more than 90 degrees. We can also have a right triangle in which one angle is 90 degrees. So this triangle is considered a right triangle. We also have an equiangular triangle. And that actually is exactly what it sounds, equal angles. So all of these angles are going to be congruent. And the last kind we have is an acute triangle. And what that means is each of the three angles have a measure of less than 90 degrees. Now, so far we've talked about theorems and postulates, but we haven't talked about corollaries yet. A corollary is a statement that is proved easily by applying a theorem. So you're taking a theorem and we're feeding off of it. So it's connected to the theorem in a way that you'll see in the examples that we have coming up. Our theorem says the sum of the measures of the angles of a triangle is 180 degrees. Now that's something that many of you probably already know. You learned it in a middle school math course or even an upper elementary school course. So we know that when we add the three angles together, they're going to give us 180. Now, we have four corollaries that feed off of that are related to that. So the first corollary in blue says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So basically that's going back to the point, it doesn't matter what I make the measures of the angles, in the end my triangle can only be 180 degrees. So for instance, if one angle of a triangle is 30 and the other one is 60, and they're congruent to two angles of another triangle that are also 30 and 60, because they add up to 90, that third angle in both triangles has to be the same. It has to be 90, so those third angles have to be congruent. The second corollary in pink says each angle of an equiangular triangle has a measure of 60 degrees. Now again, because the measure of an angle of a triangle is 180, and if we know we have an equiangular triangle, meaning all three angles are equal, if we take 180 and divide it by 3, we know each of those measures of the angles have to be 60 degrees. The corollary in green says, in a triangle there can be at most one right angle or obtuse angle. So we know that the sum of the measures of the angles of a triangle is 180 degrees. So if we happen to have more than one right angle in a triangle, that would be 90 and 90 already, and we wouldn't have any measures left for our third angle. So that's why there can only be at most one right angle. The same idea holds true for an obtuse angle. Since an obtuse angle is greater than 90, we only have room for there to be one obtuse angle. Otherwise, our sum of the measures of the angles would be greater than 180 degrees, which would not form a triangle. Our last corollary in purple says, the acute angles of a right triangle are complementary. Now again, we know a right triangle has a right angle, so we know that our sum is going to be 180. So if our one triangle is right and 90, then we know the other two together have to add to 90, so those two acute angles have to be complementary. Our next theorem says the measure of an exterior angle of a triangle equals the sum of the measures of the two remote interior angles. So our exterior angle is outside, and then we're talking about two remote interior angles. So we're not talking about the angle that's next to the exterior angle. We're talking about the other ones. So 30 and 70, they are considered the remote. They're away from a little bit. And they're interior angles. They are inside the triangle. They're interior angles. So what this theorem says is, if I add them together, 30 and 70, that gives me 100 degrees. Our exterior angle is also going to be 100 degrees. Now the reason that holds true is, think about it. A straight angle is 180 degrees, and the sum of the measures of a triangle is 180 degrees. So if I figure this out, 30 plus 70 gives me 100, then I know this angle right here has to be 80, because that will give me a sum of 180 degrees for the triangle. At the same time, if I do a straight angle, I know that this is 80, so I know this start angle is equal to 100 degrees. So I don't have to go through figuring out the 80 and then going to the 100. I can just say I know because of this theorem that if I take 30 and 70, add them together, I'm going to get the exterior angle, which will be 100 degrees. Now let's take a look at some triangles. It says find the values for x and y. So I have a triangle there. I also have some parallel lines. So these are my parallel lines here. This line right here is my transversal. Because of that, I can see that x and 110 degrees, they are corresponding angles, so they are congruent. That makes x equal to 110. Now again, working with the theorem we just talked about, my x value, the 110 degrees, is an exterior angle. So if I look at my remote interior angles, which would be 40 and y, I know that when I add them together, I need to get this 110. So I know 40 plus y is equal to 110. So therefore y is going to equal 70 degrees. So there's my x and my y. And looking at our next example, I notice that I have two right triangles, and I have a lot of different things going on because they're overlapping. So if I look at the triangle that's shaded in green, I know that I have a 90-degree angle because I have a right angle right here. I know when I put these together I get 60. So I know the value for y has to be 30 degrees because, again, in looking at that green shaded triangle, I know that the sum has to be 180 degrees. So that makes y equal to 30 degrees. Now I'm going to use this y is equal to 30 to try to figure out what x is. And looking at this second triangle, I know I have a 90-degree angle. I know I have this 20-degree angle. So I know that x plus y has to equal to 70, so that my sum of the angles of a triangle equal to 180. So that gives me x plus y, I know is equal to 70. I've already established that y is 30. That gives me x plus 30 is equal to 70. So I know x is equal to 40 degrees. Now in our last example today, we have two triangles there and we have parallel lines. So I notice that if these lines are parallel here, this right here makes my transversal. And I notice that 30 and x are alternate interior angles. So that gives me x is equal to 30 degrees. Now that I have that established, so if x is equal to 30 here, I notice that y is actually an exterior angle. And my 50 and my 30 become my remote interior angles. So then I know that y is equal to 50 plus 30, because y is my exterior angles, and the 50 and 30 are my remote interior angles. So because of that, I know that y is equal to 80 degrees.